Hey all, in this tutorial we're going to implement stack by using linker list. So let's get started. So first of all, let's create a couple of helper classes which we're going to use in this program. So the first helper class is node class, which is used to build the linker list behind the stack. So inside this node class we're going to use couple of fields. The first one is uh, next of node type, which will be holding the reference of your next node. Another one is data of integer type, which will be holding the value of your current node. And let's quickly create one uh, constructor so that we can inject the value of current node from outside. This dot data is equal to data, right? So this is the one helper class, and another helper class we're gonna build is stack or stack service linked list service, right? So inside this stack linked list service class, we're gonna write a stack operation. So the first one is push. When we want to insert something into stack, we're gonna use push operation. And when we need to delete or remove something from stack, we're gonna use pop operation. And when we know the top element of stack, we called peak operation or top operation. So let's quickly build this methods, and the method name will be push, right, which is expecting integer of data of integer type as input parameter. And here let's quickly verify whether stack is empty or not, because we need to verify whether if stack is empty, then push that element as a first node of the stack. So how we are going to check that? So for that we're going to use another helper variable, that is top, and we're going to check whether this top is null or not. If it is null, then we're going to create one new node with the current data, and we're going to assign that new node to top, right? Let me demonstrate it what I am explaining. So let's say this is a new node which we are trying to add into stack. So right now stack is empty, right? So how it is going to add, right? And there is a top helper variable which is initially pointing to null when stack is empty, right? So as we are going to add one new node which is having data 10, so when it is going to insert into stack, so will this top will start pointing to first node which is 10, right? So that is what we have done. If it is null, then add a new node and assign top to the inserted newly inserted node which is 10, because always top will be point to the first node of the stack, first in the sense the top node of the stack. All right, so if it is not null, what we can do in that case? So if we already have some nodes in the stack, 30 and 5 and 12, so our top variable will be always pointing to the top node of the stack, right? Now let's say we are going to insert one new node which is 18, right? Now it will be checking whether top is empty, top is null or not. Top won't be null because top is pointing to the uh, top node of the stack. Now it is not null, so what we're gonna do? We're gonna add this node on top of the 10 node, right? So how we gonna do that? We're gonna do that by creating a new node here. Node is equal to new node by passing the current data which is of type integer. Now how we are going to pass. So this is a new node, right? New node next is right now null. Node next is pointing to null, right? So this new node next should start pointing to here, and top will become, this new node will become top, right? So for that, let's do that. Node dot next is equal to top. So this node dot next, which is this 18, will start pointing to wherever top is pointing. Top is pointing here, so it will automatically come here, right? Now we have to move top. Now 18 is inserted into stack, right? Now our top variable should point to the 18 because 18 is the topest element on the stack. So this top should start pointing to 18. So how we gonna do that? We're gonna do that by executing, by writing one another line, that is top is equal to node. Means node is this one. Top will be start pointing to wherever node is pointing. Node is this, so top is pointing, start pointing to here, right? That is what we have to do as a part of push operation. All right, now we have inserted one element, sorry, elements into stack. Now the another use case is, another method is when we want to pop out something from stack. So public and return type will be integer because we are inserting only integer data into the stack, and method name will be pop. So we will be checking whether top is null or not, because client might execute this method first or this operation first before performing the push operation. So we have to verify top. If it is null, then you have to print the message. This will be error message, right? And we have to print stack underflow, because when you're trying to delete something from stack and stack is empty, so it will be underflow, right? Now if top is not null, in that case we have to delete, we have to pop the topest element from the stack. So how we are going to do that? That we're gonna do by using, see, now top is this one, top is pointing to 18 node, right? Now we have to make this top variable, uh, I mean we have to change the reference of this top so that it can start pointing to this node, because we're gonna remove this node. So how we can do that? Right now top is pointing to 80 and top dot next is pointing to 10. So we have to reset this top link by using the next. So let's use removed node is equal to top, because we know that top is going to uh, decommission, right? It is going to delete. So now we're gonna move top is equal to top dot next. Now top will be start pointing wherever top next is pointing, means top is start pointing to wherever top dot next is pointing, that is here 10, and this is automatically, there is no any reference which is pointing to this node, so it will be automatically eligible for garbage collection, right? Now as we have removed this node, right, so we're gonna return okay, this should be here because we're gonna use the common variable across both of the use cases. Initially this will be null. Okay, this is, we are returning integer, so let's keep it integer only, and let's keep it -1. So here we're gonna use dot data and use int here, right? Why it is throwing error? Acha. Okay. So here, now let's return removed node, right? So We have done pop also. Now another operation is peek. So public, in peek we're gonna return the integer value back to the client, and we are going to give the name to this operation is peek, right? So peek is nothing but returning the topest element of the stack. So before that we will be checking whether top is null or not. If it is null, then int top element is equal to -1. If it is null, then print the message stack is empty, right? If it is not null, in that case there are some elements which is present in stack. So we're gonna use top dot data, right, which we are going to assign to top element. Alright, and the same top element we're gonna return back to caller method. Alright, now okay, this is the use case, right? So these are the three operation mainly which we are going to perform as a part of stack, right? So now we have implemented those. Now let's test these implementation of stack by using linker list, by creating the client program stack using linked list, stack list client. All right, stack, sorry. All right, let's create main method. Let's create an instance of linked list service class, stack linked list service class, and let's use reference name as stack, new linked list stack service. Let's call the stack dot pop operation, as I said, right? Pop operation. So what I'm trying to do, I'm trying to delete the element from stack without inserting anything into stack, right? So let's run this. Now it should return the stack underflow error, right? See, stack underflow, right? So here also, if there is any if stack is empty, in that case it should return error. So right now we haven't insert anything into stack, and we are trying to pop out something from stack, so it is throwing stack underflow error. Now let's push something to stack. Let's keep 10 and let's verify the peak of stack, which is top of the stack, top element of stack. So which is, let's run this again. It should return 10 because this is the first element which we have inserted, and that this is also a top element. So let's perform uh, some more push operation. Stack dot push 20. Then let's perform few more push operation, and 8 and 12, right? And here I have performed the pop operation. Let's print this out. Even let's keep this pop in as out, so that we can assure that this is deleting the right element. Deleted element is this one, right? And then we're gonna check the peak, stack dot peak, right? So right now the topest element here will be 10, and we have inserted 20, 8 and 12. So 12 will again become the top of the stack, right? stack dot peak, which is nothing but, sorry, 12. Yeah, 12 is the recent added element on the stack, which will become the top element of stack. Now as we have deleted the top element of stack, so means we have deleted the 12 from stack. Now the top element of stack will become 8. So here deleted element will be 12 and peak element will become 8, right? Let's run this program and verify whether our program is printing the right output or not. So top element of stack initial is 10, right? Then we have perform the peak operation, right? Peak operation here, it should be similar to this. All right, let's run this again. And here also, sorry, here also it should be same. Yeah, let's run now. So the top element of stack is 10, and then we have again inserted few more element, and again we have performed the peak operation. So after performing the peak operation, the top element on stack is 12, right? This one. Now we have performed the delete operation. So we have deleted 12. So delete element is 12, right? Now as this 12 is deleted from stack, right? So that now the the top element become 8, and we have performed the peak operation on stack, so we can verify the top element is 8. And if you want to perform again another peak operation, right? So not peak but another pop operation. So here the deleted element will become 8 and top element will become 20, right? Let's verify this. See, so first deleted element is 12, which is the top element, and then we perform again delete, then the uh, another top element is 8, which is deleted, right here. And at the last we perform peak operation, so after deletion of 8, peak element will become 20, which it has printed, right? So our assumption is true and program is working fine. So we have done with this video, guys. Thank you so much for watching this video, and stay tuned for other videos. Thank you.